Looking into the potential severe weather event on Sunday evening, early afternoon, it's looking like the 500 millibar is having some favorable winds that are due westerly. And if we compare that to the 850, where it has like the due south winds in North Texas, that is a good indicator of having some relatively strong shear. And that can be seen if we go to the bulk shear, especially at the surface, up to 500 millibars. You have 40 to 50 knots of wind shear in Oklahoma and into northwest Texas. So that wind shear is really good indicator of having the environment favorable for having supercells to develop. If we look at the Euro model for the same time, though, it is quite a bit weaker at the 500 millibar level, only showing between 25 to 35 knots, whereas the GFS is a bit stronger, 40 to 50 knots or so. So that is something that would help inhibit any storm development should it happen and follow the Euro model. Let's take a look at the bulk shear that the Euro model is having. It is also fairly weaker than the GFS, but it is still strong enough to have supercells in this environment. Because remember, we only need to have 35 knots of wind shear, which we do have both on the Euro and the GFS. GFS is just significantly stronger. So now comparing the or having the 500 millibar wind speeds, the surface and 850 with the wind shear as well. Going to look at the storm relative helicity, surface to 3 kilometers. And remember, we only need to have 300 meters per second squared with the storm relative helicity, and we have much higher showing on the GFS. And so that is a really good indicator of having a tornado environment capable of producing some strong tornadoes. So now going back a few hours, this is about 1 p.m. Central Time, looking at the daytime heating effects as well as the dew point with the background environment. I'm really liking how high the dew point is showing on the GFS. Here's the Euro. It's showing something similar. It just has a different bit of an orientation. Nothing significant. GFS is a bit further north. The Euro is a bit further south. So in general, it's a favorable environment for having storm development in the southern plains, looking at the dew point as well. So we're getting like between like 70, 75, 68 dew points. Looking at the temperature, comparing it now, we're reaching some pretty high temps in the middle of the day. So that's something that could help with sunset having the most convective development. Euro is a bit cooler than the GFS. The GFS has, or the Euro is a bit cooler further up north, whereas the GFS has more of this like heat ridge almost showing right here. So in general, looking at both global models, it is a favorable environment to have some convective temperatures reached. Now that we've looked at the dew point and temperatures, going to look at the theta E, which is pretty much a combination of the two. There's some more behind it, but it's a little too far in depth for me to really dig into what it means. So just know that it's a combination of the dew point and temperature. Higher Kelvin means higher dew point or temperature. Lower obviously means lower of either one. We have some very high Kelvin theta E and all across pretty much just North Texas up into Oklahoma. That's on the Euro. The GFS, since it has a bit of a higher range of those high temps, we're going to get more of a northward expansion of the higher theta E. There's some really high theta E pockets showing up in in eastern Oklahoma. Sorry about that. Yeah, eastern Oklahoma, just east of I-35, which I know, shocker. If you have lived in Oklahoma long enough, then you know that the I-35 corridor is exactly where a lot of the storms develop, and that also sort of relates with the dry line too, geographically geographically speaking. So high theta E, high temps, high dew point. We have perpendicular winds from the surface up to 500 millibars. It looks like it's a favorable environment right now. Not looking at a QT, looks like it is a good environment to have some supercells develop. Still looking at some background environment, the GFS is having some really persistent southerly wind flow all the way up into Oklahoma. The Euro model is having something similar, it's just a bit weaker, which makes sense because the 500 millibar was having a weaker pattern on the Euro as well. So if the GFS is able to play out, then we could have a substantial day of some severe weather if this trend continues. For the model-derived composite reflectivity for GFS, this is around evening time. This is 7 p.m. There's some convection that's starting to happen, and that is lining up with what I was seeing on all those various models. The Euro model, though, is having more of a like linear, like horizontal type system happening here, and that could be an indicator of having some damaging winds and maybe some hail embedded tornadoes in the squall line type setup. Now going back to 1 p.m., looking back at the background environment yet again, the relative vorticity on both the GFS and the Euro have these pockets of positive vorticity, which is cyclonic spin at 500 millibars, and that's what's going to help drive those air parcels up to where they need to be to have some more convection and just general instability. So here's that pocket of vorticity on the Euro model, and then looking at GFS, it's more widespread. There's this part that doesn't have much positive vorticity, but that could just be, looks like it could just be like a supercell, or not a supercell, precipitation in general impacting that area. Not too sure exactly what it is, but that's just my initial thoughts on it. Not necessarily much of a big deal. If it was more widespread, then that would be indicator of having suppressed supercell development. Now with all the background environmentals out of the way, I'm going to take a look at the surface-based CAPE. This is still the background environment for the CAPE, just looking more into the thermodynamics of it all. So surface-based CAPE, GFS, has very high CAPE in the northeast Oklahoma area, looking at Tulsa, Bartlesville, that general area. Still really high going into North Texas as well. The blend of models, that's pretty much literally exactly what it sounds like. It's an ensemble that has tons of different models that the National Weather Service puts together. It's showing some generalized areas of high CAPE in this exact region that we're talking about. The UK Met model, which is the United Kingdom's global model, is absolutely ridiculously high. I show this just because it's absolutely crazy to look at. Definitely not taking this into consideration at all because of how high it is. But if the GFS and the Euro model start to show something like that, then that could be something of concern. So let's look at the Euro's mixed layer CAPE, showing that high CAPE in a similar region as well. We have up to like 3,500, 3,300 generally. Icon is having the same area all across Oklahoma into northwest Texas. So although UK is very ridiculously high, it's still having the general region. It's giving me confidence of having the general region having higher CAPE. With the CAPE out of the way, gonna look at the lapse rates, mid-level lapse rates, see how steep they are, which they are all relatively steep in that region that I'm looking at, all across Oklahoma into North Texas. The GFS is showing that, and the Euro as well. The Euro is a bit more consolidated to western Oklahoma and into north and western Texas. So in general, it is still that same region. Icon having that same place too, having really high lapse rates. The UK Met having high lapse rates as well. So it's still all in the same region. All these models are verifying pretty well with each other. The AI models have it as well too. I usually don't like to show those, but when they all have the same concurrence with something, it's nice to look at and get like a verification almost, for further verification for the general area that will have the steeper lapse rates. Something that draws my attention is how much different the GFS surface-based cape and the Euro mixed layer cape is. So the mixed layer is a bit farther south with how strong it is, and the GFS is a bit further north with the surface-based. So what that tells me is if we put these two together, then we could have an like elevated thunderstorm type situation happening in northeast Texas or northeast Oklahoma, and that's exactly what this SKU-T is showing. We have a like a really steep or a really high inversion shown on the Euro model, and that is where the convectivity could initiate, and that would be more of a hail threat, some high precip type stuff, but not necessarily tornadoes. But if we did have the GFS's way, then there could be some pretty exciting weather happening, having a very steep lapse rate shown on the mid levels, having not much of a cap. It's pretty. It looks like it's a pretty classic type of SKU-T shown for the temp and dew points for having tornadoes to occur. But if we look at the wind profile, we have southwest winds pretty much all the way up until 200 millibars, and so that would be one indicator of not having tornadoes to develop. We still have really high mixed layer cape, really high surface-based cape. Right here is the really steep lapse rates that I was talking about, 8.2 degrees Celsius per kilometer. We also have a high SHIP too, the significant hail parameter 2.2. Anything between 1.5 and 2 is a good indicator for some large hail to develop possibly and hit the surface. So if hail is able to hit the surface, then it could be potentially greater than 2 inches. That's what the SHIP is telling us right now. If this were to play out, then we could have all hazards possible. But we don't know that exactly right now just because of how far out it is. This is on Sunday. And so it's just a good idea to continue looking at this because of how far out it is and already having these signals. I've been seeing it previously too, but that was more, it was much longer range and it was very inconsistent. I'm starting to see some more consistencies between the Euro and the GFS. So that's why I'm starting to report on it now. Especially since I'm in Texas now too. Hopefully I can get a good storm chase in before I head out. But that's for my own selfish reasons. Ultimately, we want to have public safety. So if this does play out, just please make sure you know where your safe place is. Have your plan ready in case you need to go to a shelter, stuff like that. Start thinking about that stuff now so that you don't have to in the heat of the moment and you don't know what to do. So I will keep you all updated as we get some more models coming in.